Hi and welcome to this video where we're going to be looking at the effect of pH on the solubility of a sparingly soluble salt. This is one of the scenarios that NCEA likes to consider when it's looking at factors that affect the solubility of sparingly soluble salts. So what we need to consider is whether or not the salt in question would undergo an acid-base reaction, because that's really what's got to happen if pH is going to have an effect on the solubility. Now, how do you know? Well, usually if pH is going to have an effect on it, your salt is going to be either a carbonate or a hydroxide. These are typically sparingly soluble salts, unless it's sodium or potassium or ammonium, and they produce hydroxide ions in solution. Now, the presence of hydroxide ions in solution means that changing the pH can either add or remove those hydroxide ions, which will change the pH. Okay, so let's look at some examples, or a bit more detail. So let's consider calcium hydroxide for a sec. In general, we consider calcium hydroxide to be sparingly soluble. If we add some hydrochloric acid to a saturated solution of calcium hydroxide, what would be happening? Well, to think about that, we have to think about what reactions are actually occurring. Okay, so the first thing to do is write the equation. Okay, calcium hydroxide is in equilibrium with calcium ions and hydroxide ions. Hopefully by now this is pretty straightforward. So if the calcium hydroxide is in equilibrium with calcium and hydroxide, when we add some hydrogen ions from our HCl, remember HCl is a strong acid, then those hydrogen ions will react with the hydroxide ions, forming water. This is going to have the effect of reducing the concentration of hydroxide in the first equilibrium reaction. That then is going to cause more calcium hydroxide to dissolve to replace the the hydroxide ions that have been removed, which is going to have the effect of increasing the solubility of calcium hydroxide. The other way to consider it, the second equation down there, if we write it around the other way, is considered to be the autoionization of water, right? The dissociate Kw, which is the basis of our pH scale. So if we increase the H plus concentration, then that's going to have the effect of decreasing the OH minus concentration. So the calcium hydroxide is going to try and provide more OH minus to replace the OH minus that's been taken away. So either way, the calcium hydroxide is going to dissolve more, increasing the amount of hydroxide ions, and therefore increasing the solubility of the calcium hydroxide. Okay, so here's an NCEA exam question looking at the solubility of iron hydroxide in water in a situation where the pH has been lowered to less than 4. Right? So the sort of answer that we're looking at, we've got to put equations in there. So starting off with the dissolving of iron hydroxide to make Fe3+ and hydroxide ions, and then the reaction between hydronium and hydroxide. Now, whether you use H plus or whether you use H3O+, honestly does not matter. But you must include that second equation. Okay, so the sort of explanation, at a pH of less than 4, there will be an excess of hydronium ions present in the solution. These hydronium ions will react with the hydroxide ions formed from the dissolving of iron hydroxide. As the hydroxide ions are removed from the equilibrium will shift to favour the products, or the forward reaction will be favoured, whatever you like to talk about. The equilibrium will move to the right, increasing the overall solubility of iron hydroxide. So there you have your explanation supported by equations. And that's the sort of thing we're looking for when we're talking about the effect of pH on solubility. I hope this helps. Come tune in for my last video where we talk about the effect of complex ions on solubility, and that will be where we finish off the solubility topic, other than some exam questions. See you there.